Thank you for everybody who has joined. Today is the first, like John mentioned, of one of these pop-up or lunch hour short webinars, and I trust it will add value. You will see right at the end of the presentation, you will find our contact details. So for any stainless steel information or something we might have mentioned today during this webinar, please feel free to contact us on that. So today we will talk about material certification in the stainless steel industry, the why and the how. So I've been involved on the fabrication and industrial side. I've worked with material certificates, and John has got a firm background in the mill where they actually produce these certificates. So right at the end, when we Q&A, I suppose we will be able to handle most of your questions. So let's carry on. I just want to get the controls here.
Die klanke, ek het meer sagter gesit want hy kla oor die sein. Hy hak so 'n bietjie. So 'n bietjie harder kyk of hy nou beter is.
Everybody ready? Right, so the overview, just to give you an overview of what we will be talking about today. We will talk about the background to certification, maybe a little bit of history. Oh guys, can you just mute your mics there? We're hearing you. Then we're going to talk about material certification, the real certificate, the standards and so on to which it conforms, and then the importance of material certificate in the whole value chain. We will also have a look at all the information that is available on the material certificates and how you can use it and interpret it. We will look at the different versions of material certification, and then at the end of an example, we will try and show you how to navigate the material certificates and figure out where is what on it. But as a background, I can kick off by saying that in any industry, it's of importance to ensure that the correct input materials are used in the value-adding or manufacturing process. This is of critical importance in the engineering sector, where technical parameters are many times the margins between life and death. It is required to ensure that the material received and used by the manufacturer is in compliance with the international standards and in such sort of adhere to the customer requirements. Now we fairly often we host these handling stainless steel in the warehouse and fabrication courses to our members on their premises. And we emphasize the point in those courses that the critical point for material traceability in the supply chain is when material is delivered and checked into the warehouse. This is the only opportunity that you get to really make sure that what you want is what you got. It should be accompanied by the correct and complete documentation so that the receiver, you who ordered the material, can verify the material received against what you order and whether this stuff complies to international standards. In the global manufacturing arena where we play, this is becoming more and more important every day. This process of verification is driven by a document known as what we all know about the material certificate. Now, material certification becomes an integral part of your quality assurance system, since the material test certificates provide traceability and the assurance to your end user about the quality of the steel and the methods it was actually made by. So let's carry on then. Like I've mentioned just now, quality assurance is a document, or this material certification is a document that plays a very important role in quality assurance because it certifies material properties and it gives us an indication whether the material is in compliance with certain international standards. For instance, ASTM, the European norm, or even our own SANS standards. Now, in the previous century, Germany, in the industry, they had very good German inspection documents, and they then standardized the inspection documents according to a German standard, the DIN 549 standard. And I suppose because it's a German standard, it was quite meticulously done. and it was then adopted to the European standard and then called EN for the European standard 10204. And this was first published in 1991. Now, South African industry accepts the European norm in this regard, and we've got our own South African version of the EN 10204 that was done by the Bureau for Standards, and it was published in 2007. So the official certification for stainless steel is then the European norm EN 10204, and there can be a version 3.1 and a version 3.2 to the document. Now later on we will discuss these two versions. Now certification is very important in the complete value chain. It must be maintained. It's a quality document as explained. So from end user to where the material was manufactured at the mill, we need traceability. It's a document, it's a very important document, so it must be filed, but it's also a very practical tool. So it must be used, and not only stay in the filing cabinet. Fabricators and distributors would use material certification to obviously check materials received, whether it meets the specifications of the ordered material. And you know, like I've said earlier, this is the only point where upon receiving, where you can really check. Once it's in your warehouse, all stainless steels tend to look alike. They're all shiny stuff. And after that, it's very difficult to determine what you've got and link the correct documentation to each. Visual identification, like it says there in the presentation, is virtually impossible. And test certificates allow us to identify material properly upon receiving, then organize proper storage in our warehouse. Now with proper storage, I might mention that how it works is we've got a color chart, an international color chart that gives different color coding for different grades of stainless steel. If you attend our fundamental course or you want a copy like this, you can get it off our website or just ask us via the email. So then we can organize our storage and we can make sure that we store the stuff in the correct way. Now, when we want to add value through fabrication, we can then issue it correctly from this correct storage, which means that we will have less wastage, we will be more effective and more productive and hopefully more profitable. And then after fabrication and value addition, when we dispatch it, we can link documentation to it and make sure that we deliver the correct thing to our customers. So, like I've mentioned, tester certificates are required all the way down the value chain. Your customers, and you might be a customer, like purchasers, end users, and later on we'll look at the role of third-party inspectors. They all need access to this documentation. It's to ensure conformity to the grade of material ordered and whether it still conforms with international standards, and the traceability of these materials should be maintained all the way. Then we've got, for instance, the pressure equipment requirements in SANS 347, the ASME 8 for pressure vessels and ASME standard 3 for nuclear is very specific on how material test certificates should be part and integrated into a project, and how each component, each different component must be linked to some sort of official certification of the materials. So it remains very important. Now, on the test certificate is a wealth of information. And if we ask for a test certificate, it will usually be to the standard of EN, or it must be to the standard of EN 10204. And according to this standard, the following items must be on this document: the steel mill's name and particulars, the heat number of the material, which is a chemical signature that is unique to that batch of material. Therefore, we will have a batch number. Then there will be final test results on the material. There will be dimensions of the profiles, or whether it's flat, plate, tubular, doesn't really matter. Quantity, steel grade, the standards and specifications to which this will be measured. That must be available on the document, as well as the chemical analysis to give us the chemical composition of the specific batch of steel and the mechanical test property results. This must all be contained on the test certificate. And something that's not mentioned on this slide, obviously it should be signed off by the authorized person at the mill. So we get the two versions. At this stage we know the importance, why we need the certificate, we know what we can do with it, we know what's got to be on it, but there's two versions. The EN 10204 3.1 version and then a 3.2 version. Now the 3.1 version is most likely the version that's used by most of you on a daily basis. It's issued by the manufacturer to declare that this product that is delivered to you is in compliance with the requirements stated in your order. Remember this, stated in your order. You can't expect to get stuff which you haven't ordered, but we'll get to that. This is when there's no extra requirement by the customer for third-party or objective and independent witnesses of the production and inspection processes of the material. However, it must be signed by the manufacturer's representative, who will be, like in a quality assurance setup, be independent of the manufacturing department of the mill. So for non-critical, day-to-day general stainless steel components, this certificate, material certificate, is more than adequate and you should be able to work with this. The second version is like the bottom point, the third point there states, it's the common use of this type of certificate is for safety critical components, and it gives companies some confidence within this very complex global supply chain system. So in this case, when you use this type of material, or material certificate, it will be like it's stated there, safety critical components, highly specialized material, and the specific properties of the material should be is of high critical value. Then the report will be prepared by both the manufacturer, the mill's authorized representative, like in the case with 3.1, but also the purchaser's authorized inspection representative. So two people will look, one from the manufacturing viewpoint and one from the customer's viewpoint. The final, now, this authorized inspection representative of the customer might be somebody from his own staff, or it can be one of those third parties that I've referred to earlier. Now, in most cases, it can be a company, international company like Lloyd's of London, and this final certification will be a combined declaration, combined between the manufacturer and the customer's representative, that the products supplied are in compliance with the requirements of the order and which test results are supplied as proof. So this is when you really want to make sure that you've done the right stuff. Also remember, this document has got legal legs, and it's better to have this independent inspection, this 3.2 certificate, than arguing your case in Beijing and Mandarin. It's better to have the guy in Goodwood court speaking Afrikaans. Next slide. Now we're going to have a look at the test certificate itself, and we will have a look at where all these required points of information is noted on it. So at this stage we know we need mill and customer information, which will be the mill name, address, mill and customer order numbers. Then material information, so we would like to know what type of material certificate is it. We would like to know more about the melting process, the case numbers, grades, tolerances, finishes, the technical things about the material. Then also the material testing, both the chemical and mechanical test results, to see whether we've got the grade that we wanted. And then, because in this specific case, we're talking about austenitic steel, so during the cold working process, it will harden and strengthen, and therefore it needs to be heat treated to anneal it again. Now, if you don't understand the annealing that we're talking about, the heat treatment and austenitic, feel free and find out about our next fundamental stainless steel course, and after that you will be a real expert. So we will have some information on the heat treatment and corrosion testing, and then some other comments which the mill might think is important regarding this batch of material, and then obviously the signature of the works expert. So this is typical examples of material certificates. And you will see these things look fairly daunting and a bit crowded. So for the example that we're going to use, the material certificate that we could find that is most suitable is the Columbus one there on the left, because it's not as cluttered as those other ones. There's no favoritism. Right, so at the top of the certificate, we start off with there at the top left-hand side, we start off with Columbus Stainless Steel, the mill's name, and all the physical detail regarding the mill. It even mentions there it's a subsidiary of Acerinox. So we've got the manufacturer's detail. We've got some information in the next circle on the melting process. It says it was melted in an electric arc furnace, and it was then refined with the argon oxygen decarburization process, AOD. We go further. There's the customer's detail. So your name will be in there, and you can make sure that it's what you ordered. It's really it. Then we've got the inspection certificate. The type there, the version is 3.1, and it says it's to the EN 10204 standard. That must be on the certificate. The next block there is the customer order number, and then some internal order numbers and reference numbers, as well as some special requirements that the customer might have. The next block is the specifications to which this material complies and against which it was manufactured to. So there you will see we work according to the EN 10088. There's the ASTM A240, which is popular here, and it also conforms to the ASME specification there. The material grade is mentioned. Now, this is the one thing that we don't like on the European side. They refer to the material as a 1.4301, whereas the Americans refer to it as a 304. We follow their example. Right, there you will have the internal process case numbers, the material number, and the mass of the two pieces. Look at the material number just to give you an idea of what all those things mean. The first 6 digits, that will be the heat number. The 2 after that will refer to a slab, and the BB or the BA will refer to a specific point on the slab where samples and tests were done. So the traceability at this stage is pretty good in the mill, if you look at what the information is they give to us. I referred to there on the previous slide to the standard A240. Here is the first page of that document. It is a standard that will give specifications for chrome, that is the ferritic stainless steels, chrome nickel, that's the austenitics, for steel plate, sheet, and strip. So in this specification, you will find everything that specifies that specific product. That is the international standard for the specific product and how it should be manufactured. Now, part of this, table 1 in that standard, will give you on the left-hand side all the relevant material grades. The one we're talking about is right there at the bottom, the 304. And it will give you a chemical analysis of all the alloying elements and the percentages contained in the specific grade. In that same document, you will also get table 2, which is the mechanical properties for the different stainless steel grades, once again on the left. So now, on your material certificate, you can now compare the chemical composition and the mechanical properties to that contained in the standard and see whether it complies. So let's see, this is the middle part of the test certificate. Let's look at what is noted here. First of all, there's some information on the product. It is, we know from the previous section, it's 304, so it's cold rolled. But because it's cold rolled, it will work harden, and therefore it's got to be softened up again by the annealing process, and then its final surface finish will be polished to a number 4 finish, or in some markets it's also known as a 2G finish. Now once again, cold rolled, annealed, work hardened. If you're unsure about that, join us at the fundamental course. At the top, you see tolerances. Once again, 3 standards to which the product will comply in terms of its geometric or dimensional tolerances. We work, and I'll show you the example now, to the ASTM A480 standard. We'll show you the example now. In this block, we see some technical information again, the heat number, the type of material, quantity, the total mass, and then also the dimensions. You will see in the ASTM A40 document, the width of the material is important in the physical tolerances or dimensions. So in this case, it's 1 millimeter thick material. It's a 1.5 meters wide coil, and we'll look at the tolerances on all those things now, and it's a coil. So there, from the previous standard, we could then compare the chemical composition, whether it complies, and we can do the same thing with the mechanical properties. Now, some tests would be done on the finished material to see whether it is resistant to corrosion. We'll get to that after the A480 specification. There you see the front page again. And there you see a table that will give you on the left the thickness of the material, and then for the plate width or the coil width, under a meter, over a meter, and less than 1.3, and then over 1.3 to 2.1 meter width, it will give you the thickness tolerances. Sometimes we are unhappy. We order 2 millimeter material and it gets to us as 2.11, and we wanted 2. But this is all within the specification. It's allowable. So make sure, once again, that you know what you're going to get before you order it. In that same standard, there's another table giving us the variations in width of these cold rolled coils. So once again, on the thicknesses, you will have different widths and the tolerances on that. So sometimes we complain about the plate not, the full sheet not able to fit in a frame. It's a little bit too wide, but that's because of the acceptable tolerances still. Now, with stainless steel being a very reflective material, surface blemishes and little dents and warping is very, very visible. And therefore, flatness on stainless steel sheets is very important. On this table, you will see 3 sections, top, middle, and bottom. The top one is what you currently get if you don't state anything regarding the flatness of your material. You will see that the flatness tolerances there on material less than 1.5 millimeters thick is quite high, 10, 12 millimeters. And that would be in cladding and aesthetic applications, it would be unacceptable or very difficult to work with. But if you specify in the middle section a stretcher level standard of flatness, then the mill will adjust the rolling. They've got these stretcher levelers built into the process, and they can improve with that addition of work. They can improve the flatness of the material drastically if you look at the right-hand column. But being austenitic material, and once again, come to the fundamental course if you don't understand, while the material has been cold rolled, it would work harder. They anneal it, but you don't have to anneal it because some customers would like the material in that work-hardened state. So you can order your material as half-hard or quarter-hard, and because of this process, you will also have some flatness issues and certain tolerances. That is all specified in the bottom part of the table. Then we also have to look at the weight. Sometimes we buy material and we think that we've been done in with 2 or 3 kilograms. Now this is what the standard says. If it's 5 sheets or less, and the estimated weight is less than 100 kgs, it may actually weigh 10% heavier. The same thing applies, or something similar applies to more than 5 sheets, more than 100 kgs in total, where it actually may weigh 7.5% over the theoretical weight. Now, the theoretical weight is calculated by means of density factor. You will see it there in the bottom 3 lines. Now, that's a factor we use with the surface area of the to determine the weight. Now, with the chrome manganese nickel, that is the series 200, below it the 300, and then the ferritics right at the bottom, you've got the theoretical values that you should be using. But you will pick up that right at the bottom, the ferritics, the 3Cr12 has got a very different density factor to what is stated there. And that's why sometimes you will feel that your supplier has given you a little bit of a bigger invoice. But this is the theoretical value on which they calculate and on which you should also calculate. Right, back to the material certificate. This is the bottom section of it. So I've spoken about the intergranular corrosion, or the corrosion test that would have been done. You see there was 2 tests done, one according to the ASTM standard, one to the ISO standard. It passed both. But because of that material, that it needed to be softened up a little bit. In this case, it's fully annealed. It was annealed at that very high temperature of over 1,000 degrees, and then it was quenched by air or water spray. Quench means bringing down to room temperature again. The mill, in this case Columbus, feels that it's necessary that you also are informed of the following information. It contains things like there's no mercury contamination, that the radiation levels are low enough, that the material meets some hardness criteria as specified in certain standards for specific industries such as the automotive industry. And then lastly, very important, the Columbus stainless steel works expert signature, making this document official. And now it has got legal legs. So that basically brings us to the end of this short presentation. We will now go into a question and discussion session. There you see our details. Please feel free to contact us on anything that we've mentioned here today. But as a summary, and just to finalize, I can maybe mention that the trick with stainless steel and the certification is to first of all understand what you need in terms of material requirements. Have a good understanding. Then specify that in your order. You will never get a material certificate if you don't ask for it in your order. So make sure that the generic information on your order form is already there, asking for a material certificate to a certain standard and a version. But you also need a competency once it's delivered to make sure that you've got what you've asked for. So that's when understanding stainless steel and the material certificate becomes very important. So if you stick to those few basics, I think you will find working with stainless steel can be nothing else like our slogan says, simply brilliant.